Hello everybody, welcome to my channel Techie Math, where we do math but in a techie way. I'm Peter Farrell, teacher, tutor, trainer, and author of some books on exploring math topics using Python. Today we're tackling the traditional math class topic of perpendicular bisectors. We're looking for the line made up of all the points equidistant to two given points. This is often done geometrically with a compass and a straight edge, but sometimes it's done algebraically. We'll solve it a few times algebraically, and then automate the process by writing functions in Python to do the boring stuff for us. We'll make sure it works and then show how fast it makes these problems in the future. Here's a few problems students are expected to solve algebraically. The first step to solving a problem using a computer is doing it by hand. We'll do it by hand to figure out the method, and then teach that method to the computer. We'll be using the Python programming language. First problem is find the perpendicular bisector of the segment with the endpoints 1, 5 and 4, 6. We can graph this by hand to get an approximate answer. The first step is to find the midpoint of the 2 points, then the slope of the line between those points. The line perpendicular to that line will have a slope that's related to the slope we just found. The perpendicular slope is -1 divided by the slope of the segment. Next, we find the equation of the line through the midpoint with the new slope. Let's put a timer on the screen and see how long it takes to solve the first problem by hand. First, we find the midpoint by finding the average of the x values and the average of the y values. We find the slope of the segment between the points by dividing the change in y by the change in x. To get the slope of the perpendicular bisector, we divide -1 by the slope we just found. A line really just consists of the slope and the y-intercept. We have the slope, and we have the x and y of our midpoint, so all that's left is to solve for b, the y-intercept. That's y minus m times x. We plug those values into y minus mx to get the y-intercept. The slope is -3 and the y-intercept is 13. So the perpendicular bisector is y is equal to -3x plus 13. How do we check our answer? I guess we have to use an online grapher like GeoGebra. By the way, that took 2.5 minutes. So doing 20 of those problems by hand would take 50 minutes. Now we'll just solve the next 2 problems in fast motion and get our answers. Here I am in the PyCharm Python editor. This is a popular editor. You can use any one you want. If you are only online, you can use a different editor. This is the light theme. I like this better than the dark theme. That's nice too. Here's our points. This is our first set of points. Notice that we've made them into lists with parentheses, actually tuples, since we're not going to be changing these points in the program. And here are the steps that we used when we solved it by hand. First, we find the midpoint, then the slope of the line, and then a line with the inverse, actually the negative inverse of the slope, and the y-intercept is y minus m times x. So those three are going to be functions. So the first function should be a midpoint function, and I'm going to mute my keyboard. So what I've done is just take the average of the x values and the average of the y values. A and b are 2 points, and the first thing in each point is the x value, and the second thing in each point is the y value. So the indexes, index 0 is the first thing in the tuple or the list, and index 1 means the second thing. So this should give us the midpoint. Let's test it out. Let's print the midpoint of P1 and P2. Run that. 2.5, 5.5, which is what we got by hand. Good. So it's checking out. Next, find the slope of the line between the 2 points. We'll write a function just called slope of 2 points, and we'll use the rise over the run, the difference in the y values divided by the difference in the x values. This should give us the slope. Let's print it out and run it. 1/3. Yep. So to find the perpendicular bisector, we found the line given a slope and a 1 point on that line. This time I'm not going to fuss with all the indexes. I'm just going to assign x and y to be the first thing and the second thing in the point, like that. So we could do this all in one line, or we could do a perpendicular bisector function, but it's going to put all those three together. Why not? Okay, the perpendicular bisector is going to find the line with the slope being the negative inverse of the slope through those 2 points, and 1 point on that line being the midpoint of that. So we print out the perpendicular bisector. Let's run it. So this is the slope and the y-intercept of the perpendicular bisector, which is what we found before. -3 is the slope, 13 is the y-intercept. Okay, so that might have taken us 4 or 5 minutes, but now when we plug in other points to that, it should take us just a second. 1, 2, and 5, 4. 1, 2, and 5, 4. We run that and we get -2x plus 9. Yep. That's what we got before. And finally, 5, -8. And -2, 13. And it was 1/3 x plus 2. Yes. So that's how to calculate the perpendicular bisector using Python, or any programming language, really. An extension of this would be to graph this using a graphics library like Pygame, or processing, as I did in my book, Math Adventures with Python. If you made it all the way to the end, leave a like and a comment, and hope to see you in the next video.